Methodology in the social sciences keeps evolving and generating debates. The role of models, design, tests, and many other topics have been a part of heated discussions in the past few years. On this episode of Research at the Albert Hirschman Center on Democracy, we examine these topics with Matias Lopez, postdoctoral researcher at the center, and his guest, Professor Jake Bowers, a leading methodologist at the University of Illinois at Urbana-Champaign.
So, Jake, how are you? Good to have you here.
I'm great. Great to see you, Matthias.
Well, thank you so much for being with us and for taking the time to talk to us about methods. Now, why does the subject of methods get on so many people's skin? And how can we think of research designs that are more efficient and fresh? The first question that I would like to make to you is regards to design-based and versus model-based research, which I know it's a subject that you're very passionate about. Now, could you talk a little bit about these approaches and how you differentiate them?
Yeah, sure. Mostly I differentiate between statistical inferences justified using appeals to our research design versus statistical inferences that we justify by appealing to some data model. There's lots of different uses of the word design and use of the word model, but, I suspect that you're interested in this question of how do we justify our p-values? Where do our p-values come from? Where do our confidence intervals come from? If we have an estimator that we think of as unbiased, how would we know whether it was unbiased or biased? And those are two main approaches to answering those sorts of questions. The design-based approach is conceptually very simple. The whole idea of statistical inference is to allow us to infer, right? To guess at that which we cannot observe. So, on the one hand, I could run an experiment and say, this is, 10 more people in the treatment group voted for the candidate after I told them the candidate, was great. That's a description of what happened in the experiment, and it's valid and maybe theoretically quite fruitful. However, if we imagine that, for example, that I could have randomized differently, different people might have been in the treatment group and the control group, then we might want to ask ourselves questions that arise from statistical inference. How much given that it could have turned out differently, how strange would it be to see what I see if in fact there were no relationship? That's the question. A p-value answers, or what is a range of plausible answers? That's from plausible results across different reruns of the experiment. That's the answer, a confidence interval.
One easy thing about confidence intervals is they are talking directly about the effect or the quantity or the quality that you're trying to estimate. Whereas regarding p-values, that's a whole different story. And I feel that may be confusing, especially to students at times.
I very much agree about confidence intervals. I would love to see people talk about them. Mostly I see people say 0 is in the confidence interval or 0 is not in the confidence interval. It's a hypothesis test. But if they said, it would be the range of plausible hypotheses goes from -5 to 10. And yes, 0 is in there, but notice that 15 is completely implausible. 15 is way outside. And the previous studies, in order for this to really matter in the world, you have to have an effect bigger than 10. So that seems really important. Or, confidence intervals are intervals, and what's outside of them is important, as is what is inside of them. So I would love to see that kind of discussion, kind of almost borrowing from the Bayesians, really, to talk about intervals and things like that.
Yeah, they seem also more intuitive, I think, across disciplines and things that people research, right? Because this the ideal experiment sometimes is too far from what people are studying.
So another nice thing, if you did that, is it would also reveal to you that you are using particular test statistics. You could have different confidence intervals for hypothesized effects for different test statistics, and so that gives you maybe more flexibility than the existing kind of regression table style approach.
Yeah, now let me go back to one thing you mentioned, right? You're saying that one of the strengths of a design-based approach is that it makes it easier to hypothesize what would it happen otherwise. Now, you didn't use the term counterfactuals or causality, but I know that you're a big buff on causal inference. So I would ask you to talk a bit about how these different types of research, design-based and model-based, relate to causality.
I think that, the statistical study of causal inference has been focusing on counterfactual causal inference. So causal inference is the act of inferring or guessing about why something occurred in the world. We observe perhaps a relationship between two variables. We'd like to imagine that one variable drove the values of the other variable via some mechanism, and that would be causal, but we just observe perhaps a number, and we'd like to, when we wonder whether there's this kind of like asymmetric driving style kind of relationship. There are basically three main approaches to this, or possibly four. Let's start with the model-based one, where you say, I have, a story about how, contact with people of different groups changes the attitudes of a person toward out-groups versus in-groups. And that runs through, it's important that I have a contact with different groups in cooperative contact versus competitive contact, etc. And I have an outcome variable. I'm going to measure, say, prejudice. Actually, there's a great project where we have traffic cameras watching people on the streets of New York City. They randomly assigned black and white civilians, and they watched the distance between people as they walked by them. So the outcome variable could be meters of distance. In this kind of a case, what you could do is say, look, I have a data model, and I'm going to use a Poisson model for a number of discriminatory acts, maybe zero inflated. I'm going to model each individual as being independent of each other. I'm going to measure the number of encounters they have with other groups, and I'm going to have a full likelihood model, and I'm going to predict for each person how they would have been. I'm going to fit that model. How does exposure to groups change the parameter of discrimination? Now I have a prediction. I see what they did in one condition. I predicted what they did in the other condition, and I can compare the two things. That would be a causal inference. It's called predictive or model-based causal inference. So in the world of modeling, of data models, this is not theoretical models, but data models, it involves predicting for each person. It's almost like the machine learning approach, right? So predict what you think someone's going to do using all the power of our predictive machinery, like machine learning, Bayesian or not, and then compare for each person. The design-based approach uses either estimating average causal effects, which is a very common thing to estimate. You can show that the difference in means of, say, a treatment group and a control group in a randomized experiment is an unbiased estimator of the unknown difference in means that we would have seen had we given everybody treatment or everybody control. And that's an amazing thing that we can learn about how the treatment group would have behaved, even though only part of the treatment group was in there. Same thing in the control group. That's the estimation-based approach, often affiliated with Jerzy Neyman. The Fisherian approach is to say, I'm going to hypothesize about what I might have seen. So for each person, I'm going to imagine that the treatment would decrease their discriminatory actions by 2. And then I'm going to ask myself, well, what's the evidence against that claim, given what I actually observe? I observe a bunch of people acting. How strange would it be to see what I observe if 2 were the correct answer, or 0 were the correct answer, or only people who were in competitive circumstances, cooperative circumstances, had this answer. So there are multiple ways to do statistical inference, to learn about counterfactual, to do causal inference. They all work fine in their context, and they all have their own burdens which are often shared with statistical inference techniques.
Now, we didn't mention this, but when we talk about causal inference, right? So the other side of the table is the descriptive inference. In many times, people are just interested in knowing how things are, right? And that's assumed to be descriptive inference. And although that's framed as merely a description in social science, at least there's always the assumption that, the world could be different, right? So there's always this counterfactual thought experimentation about how things could have been. So my question is, is it really such a sharp division between estimating a causal effect, which is a quantity, and estimating a quality or some other quantity that we don't assume to be caused by anything necessarily?
I think there are differences, but all of these approaches to learning about the world are valuable. Let's make that be clear. So if I wanted to do population inference where I have a sample, I'd like to learn about a population. I draw a sample and I find, the proportion of people vaccinated, but I know it's a sample, and in another sample, I could get a different proportion. There are, we have good ways to estimate the population proportion, which is unknown to us. So that's a description of the population. It's a statistical inference to the population, or we say it's a population inference from a sample, inferring from a sample to a population. It's also a description of the population because that's what we're trying to do. We're trying to say what is occurring in this population. Now, there's another form of work which doesn't have a population or a sample. I might be doing some kind of theoretical inference or something like that. Maybe inference is the wrong word, but I say I have a theory that says I should not discover, democracies with elites that are electable having coups because elites are part of the power structure, so they shouldn't appeal to the military. And if you discover some and you say, look, there are two, here they are, that's super interesting. That casts doubt on an argument, on a theoretical argument. And it makes us wonder, maybe we need to rethink the theory, or maybe we need to do something else. And in that case, there's no inference. That's description, but it's very important description, right? Then, of course, it's also theory laden. Like we went looking for something because we had certain kinds of theories and certain kind of observations have value to us. We think of them as, the newspapers have value, whereas talking to, somebody on a street corner has a different kind of value. So I agree. There's kind of an inference there, but it isn't as structured how we put those kind of observations together to address questions like, how do you know what you know?
Right. So far we tackled two big divisions in methodology in social sciences, which is, design-based approaches versus model-based approaches. And now we were talking about causal inference versus descriptive inferences. And of course, you have this universal idea. There is something that is quantitative or quantitative, and there are things that are qualitative. And that's also a sharp division. Do any of these other divisions or all of them make sense to you? And how do you relate to them? How do you relate to people? They say, oh, no, that's quantitative, I'm qualitative, or vice versa.
Well, I liked how I think you revealed to me something. When people will say, I'm qualitative, right? So on the one hand, I'm not a p-value. And p-values exist independently of me. It's like I'm not addition. I use addition and subtraction. I force my children to learn addition and subtraction, but none of us identify. It's not important to our identities. Or I hope that my children think of themselves as kind, creative, sharing people, and not as mostly as good at math. So there's an identity aspect to all of this, and it's hard to escape, I think. We have a lot of problems facing us, so we need all hands on deck. And we should be able to criticize all possible ways as well. An ideal approach is when the person says, here are the grounds on which you can criticize me. And they're really hard grounds, right? So p-values have errors. Similarly, when I did in-depth interviews, this was in Chile a long time ago, people would say, how do I know, that these people are not just reacting to you? So you had a discussion. What I'm not learning about ordinary people's civic life in the first year of democracy after a dictatorship. What I'm learning about is how people react to you. And so I have to respond to that. I have to respond about whether or not my p-values, my appeal to the central limit theorem for my p-values is justified. I liked how you began this podcast, which is why are we get riled up about these things? And I think it has to do in part with investment. It's so hard to learn to do anything that we do. It takes many years. There's a mastery aspect of this kind of a craft. And so it's reasonable to be proud of yourself to be able to do whatever you've invested your time in. And it is difficult to be criticized, which we must do. I see value in it all. I know what I'm better at and worse at. I have a very good friend that I worked with a ton, Kathy Kramer at University of Wisconsin. And one thing she's amazing at is going into bars in Wisconsin and hanging out with people. She's written 3 books. What she's really good at is this, dealing with the incredible amounts of information that come from open-ended discussions of small groups of people and interpreting them. I, for some reason, have been rewarded for special abilities, not talking to people in bars, but playing with computers and writing computer programs. I don't feel worse about myself because of her amazing abilities. And I don't think she feels worse about herself because of my reasonable, probably overpaid abilities. We can get along because we've been friends since our first years of graduate school. But I think that it's difficult. I think that many places make this into an identity issue. When I was in graduate school, there were a group of people who would say, I'm a theorist. And we'd say, well, cool. I mean, we're all here reading Foucault together.
But I would like you to talk a little bit about your coming book on field experiments and teaching field experiments. Could you talk a little bit about it?
Yeah, absolutely. So this group that I'm a part of, Evidence in Governance and Politics, goes by EGAP, has been traveling the world teaching investigators in Africa and Latin America about how to do field experiments. We have a 1-week course that we've been doing. It's 5 days called Learning Days. At the end of it, the people write a research design. And they learn about how to assess the error rates of their tests and about estimators and power analysis. And it's kind of a stats course with a big dose of ethics and stories about how things go wrong in the field, et cetera. Over time, we realized that it is not necessary to have academics from mostly the US and Europe fly to the global South to do this work, because there's a ton of great people who are investigators there with great skills, but who just need a little bit of support. So we collected all of our materials and did a very big rewrite of them and have released them for free on the EGAP website, so that instructors who are teaching these courses anywhere can use them. So we have slide decks, we have links to resources, we have, key bullet points. Here are the 5 things you should know about causal inference and experiments. It's about experiments, so it's not about the broader questions. It's self-consciously focused. And we've just translated it into Spanish, including many of the slides. And the French translation is beginning now. So the idea is to have an accessible set of materials for instructors anywhere in the world to use to learn about, to teach about, and also learn about causal inference in randomized experiments.
That sounds great. I'm eager to read it. I thank you, Jake, for being here with us, and I thank you for listening. I'm Matias Lopez. I'm a researcher here at the Albert Hirschman Center on Democracy. You can follow me on Twitter if you want and be follower number 6, I think, at Matias Lopez UY. And where can we find you, Jake?
I'm at jakebowers.org is my website, where I put lots of different materials, and I have a Twitter account, but I don't post from it. So just go to my website, jakebowers.org.
It's good that there are not so many Jake Bowers in methodology, I think.
Yes.
Thank you for listening to this episode of Research at the Albert Hirschman Center on Democracy. Make sure to subscribe on any podcatcher of your choice for more episodes like these.